Okay, so got a question last night from a student via email. This question is TRO, page 213, number 35. This is chapter 5, gas laws. In particular, I believe it's partial pressures. Partial pressures, okay. So, number 35. A gas mixture contains 1.25 grams of N2, and so this is a mass, formula weight, in moles. I do this as a habit, right? And it also contains 0.85 grams, 0.85 grams of O2, and so we'll get the formula weight of that in a second, in a 1.55 liter container. All right, so volume is equal to 1.55 liters. 1.55 liter container at 18 degrees Celsius. Temperature is equal to 18 degrees Celsius, which I'm going to say plus 273. I'm going to go straight to Kelvin because I'm always do that. It's almost always asking about kelvins. So 273 plus 18 is 291 kelvins. Okay. Calculate the mole fraction and partial pressure of each component in the gas mixture. Okay, so what we need is the mole fraction of N2, the mole fraction of O2, the partial pressure of N2, and the partial pressure of O2. All right, so we're going to do this a couple different ways. I might need 2 pages for this, but for now, let's say we're going to go here. So what's the formula weight of N2? Nitrogen is 14.01, so N2 is going to be 28.02, and that's in grams per mole. I'm going to keep things clean here. I don't want to put the grams per mole there. But I'm going to suppose that the viewer of this video has done this enough that they know how to get this. If it's grams, it's going to be divided by grams per mole. 1.25 divided by 28.02 is 4.46 times 10 to the negative 2. This is 4.46 times 10 to the negative 2. Okay, and 0.85, the formula weight of oxygen is 16, so this is going to be 32. It's 16.00, so it's going to be 32.00. So 0.85 divided by 32 is equal to 2.66. 2.66 times 10 to the negative 2. All right, and the volume. So what's the N total? Okay, N total is equal to the sum of these two. It's 4.46 plus 2.66 times 10 to the minus 2. Do that to make it look cleaner. Plus 0.04461099931. Enter, and it comes out to be 7.12 times 10 to the minus 2 moles, right? That's N total. What is V total? 1.55 liters. What is R total? It's just a joke. 0.08206 liter atmospheres per mole Kelvin. What is T total? Just kidding. 291 kelvins. And so P total is going to be nRT over V. You know where I get that? So N is, we already have what N is, 7.12 times 10 to the negative 2 times R, 0.08206. I'm going to leave the units out because I'm so careful with my units as I go along that I don't have to worry about it here. If I was doing a quiz or exam, I probably would put the units in, but because it's a video, I don't want it to be obscured by that. But those are really super helpful. 291 kelvins divided by 1.55. I spell 1 this way here. Divided by 1.55. Now, I really want to reiterate, this is very important. It turns out that those units are critical, and if I don't have the right units in there, it simply won't work. Okay, so 7.12 times 10 to the negative 2. I still have that number in my calculator. It's not actually 7.12, it's 7.1173491 times 0.08206 times 291 divided by 1.55, which is 15.477. A little fast there. 15.477. Okay, I'm going to leave that number in my calculator. I know if the question was what was the pressure total, I'd have to report that to the right number of sig figs. Clearly it's 3 sig figs, so that'd be 15.5. Okay. All right, that's the pressure total. Now we need to find the, we already have the moles of each. Now we know that the mole fraction of N2 is going to be the moles of N2 over mole total, which is equal to, where's the moles? 4.4 6, just a second here. 0.0446 109921, putting all the digits in just because, divided by 0.07117 is equal to 0.6268. 0.6268, which is reported as 0.627. Okay, so the mole fraction of O2 is going to be 1 minus that. Let's make that a minus. Clear. 1 minus answer. Enter 0.373. Okay, so those are the mole fractions of each of those. Now the partial pressure of each of those is going to be, I need a new page here, sorry. So what I have to do now is I've got to say, let me go to a new page, bam, make this page invisible. The partial pressure of N2 is going to be the mole fraction of N2 times the pressure total. So what you need to do is you need to pause the video at this point and calculate that. I understand it's routine, but you need to do it. All right, let me go back and look what the mole fraction of N2 is. The mole fraction of N2 is 0.627 times pressure total, which was what? 15.477? 15.477, which is equal to, and the partial pressure of oxygen is equal to 0.373 times 15.477 is equal to, all right, times 15.477. Partial pressure of oxygen is 5.776, really 3 sig figs, right? Oops. 5.78, and the partial pressure of the one above it is 0.6268229 times 15.477, 9.701, 9.701, which is reported to 3 sig figs as 9.70. Okay, so let's add these two numbers together real quickly and make sure they give us the pressure total. They ought to, of course. So the sum of these two is 8. 4, carry the 1, 10, 15. And sure enough, that's what it was. Okay, let's go back over here. We can disappear this now and bring this guy back up and say it's the pressure total was 15.477. Yeah, perfect. Okay, well I can't. I'm overlaying these two, right? That's not going to help you. Anyway, we'll go back and I guess you can go back and forth in the video and look at those numbers again. But the numbers we were asked to calculate were the mole fraction of N2 and the mole fraction of O2 and the partial pressures of those. Okay, so I hope that's helpful. Thank you for the video request.